solve equations that contain like terms. Think about this question during the lesson. Gianna has 36 yards of fabric to make sets of matching placemats and napkins. It takes 1 1/3 yards of fabric to make a placemat, and 1/6 yard to make a napkin. How many matching sets can she make? You can draw a bar diagram to show how the quantities are related. The entire bar represents the total amount of fabric Gianna has to work with. This part of the bar represents the yards of fabric needed to make X number of placemats, while this part of the bar represents the yards of fabric needed to make X number of napkins. Why can you use the same variable to represent the number of placemats and to represent the number of napkins? Gianna needs to make sets of matching placemats and napkins. That means she will make an equal number of each. How would a diagram help you write an equation? A diagram would help you visualize the relationship between quantities. Now use the diagram to write and solve an equation. The diagram shows that 1 1/3 x plus 1/6 x is equal to 36, the total number of yards of cloth. Convert to like fractions. 8/6 x plus 1/6 x is equal to 36. Because the two terms are like terms, we can combine them. What is the sum of the two terms on the left side of the equation?
Select your answer.
(9/6 x is equal to 36. Use multiplicative inverse to solve. 6/9 times 9/6 x is equal to 6/9 times 36. So, x is equal to 24. Gianna has enough fabric to make 24 matching sets of placemats and napkins. So, if x is equal to 24, 32 yards of the fabric will be used to make placemats, and 4 yards to make napkins. Now you can solve more complicated equations by combining like terms.
Selena spends $53.94 to buy a necklace and bracelet set for each of her friends. Each necklace costs $9.99, and each bracelet costs $7.99. How many necklace and bracelet sets, S, did Selena buy?
Selena buys necklace and bracelets for blank friends. That's what we are trying to find. So when we look at the problem, we first look at the important information. Selena spends how much money? It tells us $53.94. So we're going to underline that. She spends that to buy a necklace and bracelet. So necklace and bracelet for each of her friends. Each necklace, it says, costs $9.99. Each bracelet costs $7.99. The question we have to answer again is how many necklace and bracelet sets, S, did she buy? So the letter S is what we have to use as our variable or unknown as the amount of sets. So first, they already have identified in the equation the total amount spent here, $53.94. So for the number of necklace sets, we don't know, but we know how much they cost. So we're going to put $9.99 here. And then for bracelets, again, we don't know how many she bought, but we know the cost, $7.99. Oh, 99 cents. This pen. Okay, 99 cents. So now we have to combine the like terms because both of these terms have the variable S. on them, we know they are alike. So we then have to add or combine them together. So $9.99 plus $7.99 is equal to $17.98. That's how much it costs for one bracelet and one necklace set. Again, we still don't know how many sets, but we know the total cost she spent and the total for a bracelet and a necklace together. Now, to solve for the number of sets of bracelets and necklaces, we need to use the inverse of the operation used, which is multiplication here. $17.98 times S is equal to the $53.94. So the opposite or inverse of that is division. So we're going to divide by the $17.98 on both sides of my equation so that the S will be by itself. So $17.98 divided by $17.98 is going to equal S. So we're left with S on the left side of the equation. Now we have to take the $53.94 and divide it by $17.98. That is equal to 3. So now we have solved for the number of bracelet and necklace that she bought for each of her friends.
Celine bought a computer screen on sale for 35% off the original price. What was the price of the computer screen before the sale?
Draw a bar diagram to represent the situation. So here's the bar diagram. It says let P be the price of the screen before the sale. So before the sale, the total bar would represent the price of that TV or screen. And then after the sale, it says, let's see, the computer screen was on sale for 35% off. I showed you in a previous lesson that when you have a percentage, you have that invisible decimal at the end of the percentage and you move it over 2 places. So 35% as a decimal is 0 and 35 hundredths. And that's going to be multiplied times the price P of that screen. That will tell us how much of that the price of the screen that she's not paying for, because it says 35% off. Then the $130 here is the amount of the screen after the sale. So 100, that's what the sale price says here on the TV or screen. So $130. Now we're going to use that to write an equation. So we have P, which is the total cost of the screen, minus the 35% times that price. That's why we have 35 times P. Again, that's 35% as a decimal, and we're subtracting it because that is how much money is taken off of the price. So we're going to subtract that from the total price. And so now we have 65% P, and what they didn't show here, I don't know why, but 35% minus 100% will leave you with 65%. So 65% is this decimal 0.65 here. That represents how much of the cost of the screen she is going to pay for. So instead of subtracting that 35%, all they did was change it to the amount, the percent that she is going to pay for. So 65% times P is equal to $130. So now to get the P or price by itself on one side of the equation, we have to do the inverse of multiplication, which is division. And we're dividing the 0.65 on both sides of the equation. And so these cancel out and you're left with P. And then 130 divided by 65% or 0.65 is 200. So the price that she is before the sale was $200. And that is how you are able to use that bar diagram to create your equation.
Nat's grocery bill was $150, which included a 5% club discount. What was Nat's bill before the discount? Write and solve an equation.
Okay, so let's look at the problem. Nat's grocery bill, $150. So that would be the total amount of his bill, everything he bought at the grocery store, which included a 5% club discount. So discount, that word tells you money taken off, a percentage of money taken off of an item price. So when you go to the store with your parents and you see something that says 50% off, 40% off, discount on the shoes, there's a 50% discount off of the sneakers. They're telling you that you are taking 50% of that price off of that total price. So when you see the word discount, know that you're taking away that percentage of that price. Again, let's look at the question. What was Nat's bill before the discount? That's what we're answering, and we have to write and solve an equation. So I'm going to show you how to draw a bar graph first, since that's what the example showed us. Here is my bar. I'm going to draw a long rectangle. Now, this rectangle represents the cost of the groceries before he bought, before the discount. So G, I'm going to use as my variable. That's going to be the total amount of that grocery bill before his discounts. Now I'm going to make a little line here, and this does not have to be perfect. I'm just drawing a line to show separation between the total amount he paid for his bill and the 5% off that was taken off of that bill. So let's create our equation based on that bar diagram. As you can see, I started to show you how to make that 5% into a decimal. Remember, I mentioned in a previous lesson that there's always an invisible decimal to the right of the percentage, and you move it over 2 times to the left, and you get your decimal for that percentage. So I'm going to write my equation, and it would be G minus, because G stands for our total grocery bill, times 5% times G, because to find the percentage off, you have to multiply the percentage times the total, equals the, how much was it? $150. $150 total. So again, from the example, the 5% is what is taken off of the total bill. But if you take 100%, subtract it from 5%, you get 95%. So 95% of the bill is what Nat did pay. So I'm going to change my equation up a little bit and show 95% times G, which is total grocery bill, is equal to $150. So now when I multiply 95% times that total grocery bill, that gives me will equal $150. But we're solving for G. We don't know what that total amount is yet. So now the next step is to do the inverse or opposite of multiplication. So the opposite of that or inverse is division. So we're going to divide 0 and 95 hundredths or 95% from both sides of the equation. It cancels out on this side and we're left with G. And then we take the 150 divided by the 95%, and that equals $157.89. So the total grocery bill before the discount was $157.89.
Solve the equation -3 and 5/10 times y minus 6 and 2/10 times y equals negative 87 3/10.
To combine like terms with negative coefficients, use the rules that you learned for adding and subtracting rational numbers. So the coefficients are the numbers in front of the variable. So the negative 3.5 is a coefficient. The minus 6 2/10 is a coefficient because it's in front of that variable. So it says to combine the like terms with negative coefficients, we're going to use the rules we learned. So we have negative 3 5/10 and minus 6 2/10, which essentially makes it negative and negative. So we're going to add them up. So we would be adding both the 3 5/10 and 6 2/10 because they're both negative. And that's how we equal that negative 9 7/10. Because of that minus, it makes this number negative. So now we have the negative 9 7/10 times y is equal to negative 87 3/10. And then to solve for y, we're going to do the inverse, which is division. So we're dividing by the negative 9 7/10 y, and do that on both sides of the equation. And then when you divide negative 87 3/10 divided by negative 9 7/10, you equal 9. So the equation, when you solve it, the y is equal to 9, positive 9. Let's solve for d. So let's do the first one. And let's look at that. So we have negative 1/4 times d minus 2/5 times d is equal to 39. So we're going to, just like the example, we have a negative and we have a minus here. So we're going to look at them both as negative. So we can just combine them by adding them together. But these are fractions. We know that when adding fractions, the denominators must be the same. So we need a common denominator here. The least common denominator between 5 and 4 would be 20. So I'm going to do 1/4 is going to be equal now to 5 over 20 negative minus, I'll put that d back, and then 2/5 will be, let's see, 8 over 20 d is equal to 39. So now I have my two fractions with the same denominator, and now I can combine them. So 5 and 8, I'm going to add those up, equals 13. So now I have 13 over 20, and that's going to be negative. D times d is equal to 39. And then now I am going to divide, because the inverse of multiplication is division. So I'm going to divide the negative, I'm going to put a big line, negative 13 over 20. I'm going to do that on both sides of the equation. That's negative. Okay, so this cancels out on this side, so I'm left with d. And then I have 39 divided by negative 13 over 20. So I'm going to write this over to the side. So I have 39 divided by negative 13 over 20. And I wanted to write it this way because with that fraction, this part right here looks a little funky. So I wanted to write it the way you're used to seeing it. And when we have a whole number, we know that we can put it over 1 and it becomes a fraction. So now we do our rules for dividing fractions, which is keep, change, reciprocal. So we keep 39 over 1, change division to multiplication, and then we have 20 over 13. Again, that's still negative. Now we're able to multiply straight across. But before we do, I want to see if I can simplify. So if I look diagonally, I want to see if they have a greatest common factor. So I always start with the smaller number and divide it by that number just to see if it actually goes into it. So 39 divided by 13 is equal to 3. So 13 divided by 13 is 1. 39 divided by 13 is 3. So their greatest common factor was 13, which worked out perfectly. So now both of my denominators are a 1 And so all I have to do is 3 times negative 20. And 3 times negative 20 is negative 60 over 1, which is also equal to just negative 60. So D equals negative 60. Now let's take a look at B. Negative 9 and 76/100 times D minus negative 12 and 81/100 times D equal to 8 and 54/100. In this example question, we have a minus and a negative. So when you have a minus and a negative, it turns it into a plus. So it's all positive. So now we have negative 9 and 76/100 plus 12 and 81/100. So now, because there's a positive and a negative, we are subtracting the 12 and 81/100 from the 9 and 76/100. And that will equal 3 and 5/100, and that will be positive because my 12.81 is bigger than my 9.76, and so we take the sign of the bigger number. So now this is what we're left with. And so we're going to solve for D. So we're going to divide because that's the opposite or inverse of multiplication. And I did not mean to put that D down there. So this cancels out, and then we're left with D, and then 8.54 divided by 3.05 is equal to positive 2.8. And so D is equal to 2.8.